Hi everyone, welcome to my final project for Math 6305, which is math history. My project is titled Zero, A History of Nothing. Zero has long been ignored throughout history. It has sometimes been seen as unimportant or insignificant because of its absence of value. But zero has been a part of mathematics from the time of the earliest recorded written number system. The ancient civilization of Sumer, located near modern day Iraq, is one of the oldest known civilizations on the planet, estimated to date back to around 5000 BC. The Sumerian people used a sexagesimal or base 16 number system. Similar to our modern day base 10 number system, this system used place value to identify numbers. For example, the number 137 has a 1 value for the hundreds, a 3 value for the tens, and a 7 value for the ones. This means that there are 1 100, 3 tens, and 7 ones, which equals to 137. The Sumerian system uses the same concept, but each place could be a value of up to 59. For example, this number, which I will put on the screen, is equivalent to the number 400 in the Sumerian system. That is basically 6 times 60 to the first plus 40 times 60 to the 0 is equal to 400. This is where in history we see the first written use of a 0, if that's what you want to call it. You see, whenever there was a null value for a position in the number, the Sumerians would leave a blank space. For example, the number that would equal to 3601 in our modern day number system would have a 1 in the 60th to the second power position with a blank space after it, and then a 1 in the 60th to the 0 power position. This caused a lot of confusions for archaeologists when attempting to decipher these numerals. In any case, this use of a null value represents one way in which we still use 0 to this day. For example, the number 107 shows no value for the tens position, but it is still integral to the understanding of the value of that numeral. From the Middle East, we traveled to Mesoamerica. Another ancient civilization independently developed a 0 of their own. The Mayan civilization, located in modern-day Yucatan, Mexico, existed from around 300 BC to 1200 CE, and used a vigesimal or base 20 numeral system. This system was unique because its numerals were written vertically rather than horizontally. The number 24 would be written as shown here. That seashell-looking hieroglyph is the Mayan 0. Unlike the Sumerians and Babylonians, the Mayans figured they needed a symbol to represent empty positions in their place value system to avoid confusion when performing calculations. The Mayans were very famous for their work in astronomy, arithmetic, and calendar writing. With these numerals, even uneducated members of the Mayan society could learn to perform calculations for their own bookkeeping and other necessary tasks. This is the first instance in history that we know of where people developed a symbol for this absence of value. Whether there is a symbol for it or not, this idea of having no value developed independently in two completely separate parts of the world. This provides us with an idea of how humans developed mathematically, and the fact that neither civilization had a 0 that stood on its own as its own numeral with its own rules for operating goes to show that so much can be done without a proper 0, that, as we would call it. Both the Sumerians and the Mayans used math for extensive trade and commerce, as well as using geometry to erect massive structures. Even though much could be done without a proper 0, one man decided 0 needed to be able to exist on its own, not just as a placeholder for an empty space in a positional system. Brahmagupta was an Indian mathematician who lived from 598 CE to 668 CE, during the golden age of Indian mathematics. He is best known for his contributions to astronomy and mathematics, but most importantly, for the context of this video, he is the first person to establish rules for operating and working with the number 0. In his book, which I cannot pronounce but I will put the name of on the screen, he mentions many rules for operations involving positive numbers, negative numbers, and 0. It is important to note that the Indian numeral system used a positional decimal system much like the one we use today, only with different symbols. The symbol was for 0 was simply a dot added to the numeral. Most of these rules align with our current understanding of operating with these types of numbers. Rules like the sum of two positives is a positive, the sum of two negatives is a negative. The difference between two numbers which are the same value is either a positive or a negative is 0, and 0 plus a number is a number itself. This is the first mention in recorded history of 0 being its own number with its own properties for operating. Some other properties of 0 included in this work here are a number times 0 is 0, the product of two zeros is 0, and Brahmagupta even attempted to answer the questions which still puzzles people to this day. For example, can we divide by 0? According to Brahmagupta, you could. In his work, Brahmagupta gave rules that said 0 divided by 0 is 0, but as far as other numbers divided by 0, even Brahmagupta himself could not give an answer. From Southeast Asia, the 0 traveled to the Middle East, where mathematicians like Al-Khwarizmi, who lived from 780 AD to 850 AD, used 0 in algebraic equations. That's right, the man who algebra is named after used the Indian idea of 0 as a number to develop solutions to algebraic equations, which eventually led to 0 being part of the Hindu-Arabic numeral system that we use in most modern mathematics. During this time, most of the math that the Arabs were doing came from Greece. Greek mathematicians did use a base 10 numeral system as well, but it shared similarities to the Babylonians in which they did not have a symbol for an empty place value position. Rather, they simply left a blank space. This was not good enough for Al-Khwarizmi, as he believed that mathematics should be accessible to everyday people. His goal was to find simpler ways to perform calculations such as multiplication and division of large numbers. What we know today as algorithms, which is a mispronunciation of his name actually. When performing calculations yourself, it is okay to leave a blank space because you can remember that there should be a space there, but when reading the work of others, it is not always obvious where the spaces should be. So, Al-Khwarizmi created the modern-day symbol for 0 to put whenever there was a null value in one of the place value positions. Al-Khwarizmi's willingness to learn from other cultures led to the great advancement in mathematics as well as introducing it to the everyman. Not everyone was welcoming of this new concept of a number which represents nothing, yet is still operable. During the time of Al-Khwarizmi, the Muslim world was going through a golden age of science and mathematics. But after the fall of the Roman Empire in AD 476, in the words of one modern historian, it's as if Western civilization went camping for 500 years. The Christian world was not open to taking lessons in math from Muslims, as they believed them to be heretics who rejected their true faith. After all, what would you learn from someone who doesn't even believe in the true religion? It would take about 100 years from the death of Al-Khwarizmi till the 10th century when one curious French monk by the name of Gerbert du Aurillac traveled to Muslim-controlled Spain to study astronomy and mathematics, which were virtually absent from Western society at the time. There, he learned to use Hindu-Arabic numerals, algorithms, algebra, and how to use an abacus. Gerber went on to help spread this information to Western civilization by tutoring members of the royal family. In doing so, Gerber built his influence enough to be elected as the world's first French pope. Though his influence was strong, there was still great doubt in this new and seemingly demonic math, and Gerber could not convince the church or the people to adopt Arabic numerals before his death in the year 1006. Christians during this time hated Islam so much that before the First Crusade in 1096, the former pope was labeled a devil worshipper for having taught the math and science of the heretics. Nearly 200 years after the death of Gerber, a man by the name of Leonardo Fibonacci was born to a wealthy Italian merchant around the year 1170. Fibonacci is thought to have been the best Western mathematician of the Middle Ages. This might be because of the outright refusal to accept the Hindu-Arabic numerals, but Fibonacci thought these numerals and algebra were far superior to the awkward Roman numerals that were still widely used in much of Europe. Fibonacci learned of these Hindu Arabic numerals, including 0, through his travels, which earned him the nickname vagabond, which means wanderer. After years of obtaining this knowledge, Fibonacci decided to share this with others, and in 1202 he published his Liber Abaci, Book of Calculation, which showed you how to use the Hindu Arabic numerals along with the 0 for practical applications such as calculating currency and computation of interest. Merchants and bankers of Italy found these new calculation methods quite useful for keeping records and were much more open to them than aristocrats and the majority Christian population. Thus, this knowledge put together by Fibonacci for consumption outside of the Muslim world was scarcely shared. This, along with the lack of printing methods, made it so it took another 300 years for the Hindu Arabic numerals, along with the 0, to spread beyond Italy. 0 finally came into its own in Europe during the Renaissance when it began to show up in a variety of books, including Robert Record's popular math textbook, Ground of Arts, which was published in 1543. Robert Records is also known for inventing the equal sign and introducing the pre-existing plus sign to represent addition to Western society. Once 0 and the Hindu Arabic numerals became widely accepted throughout Europe, we start to see massive advancements in mathematics. 0 begins to make its way to multiple branches of science and mathematics. In abstract algebra, we study 0 as representing the additive identity of the monoid, that is, the real numbers. In set theory, 0 represents the cardinality of the empty set, which is a set that contains nothing. It is also the set, which is a subset of every set, including itself. In propositional logic, 0 is used to represent the truth value false. Logic is the basis for the subject of computer science, which has moved a great deal forward in the last 100 years. In physics, we see 0 being used for a variety of physical quantities, including as the freezing point of water in Celsius and as the lowest possible temperature in Kelvin. It seems that 0 might be taken for granted by modern humans, but has gone through a great deal of obstacles to reach its current state of fame. The fact is that 0 is so widely used in modern mathematics and is learned so early on in education that it seems almost insignificant. But many civilizations advanced their own mathematics without a proper 0. Though once 0 entered the mainstream, modern-day mathematics felt, in a sense, complete. Thank you all for watching and for following me down this journey through the history of nothing.